Welcome to the Kenya Bridge Project, and the purpose of our project was to design and build a sustainable and weather-resistant bridge for the people of Bondo, Kenya, that will provide access to medical facilities in the nearby area. The purpose of this bridge is to help sick villagers get across the chasm to a healthcare facility. Materials such as concrete and steel are pricey and limited, so we suggest materials such as stone and eucalyptus be used for the bridge.
As you can see in the picture, there's a chasm that is 100 meters deep, and the bridge is going to spread across this chasm for villagers to get across. The surrounding soil is mostly sandy, and it's hard soil underneath.
Other requirements of the bridge: the area where the bridge is located floods a lot, and there's already an old bridge there. So we have to create a bridge that would be tall enough to avoid the flooding. The chasm spans across 30 meters, so the bridge would obviously have to be longer than that. And the bridge also needs to be wheelchair accessible.
This is a chart of the design process. So far, we've covered the interview, research, and we are currently working on the design portion of this process. The rest of it will come later.
So through multiple interviews with the client, we've gathered quite a bit of information. So let's tell you how the interview process went. Because our client Noah lives in Kenya, we've communicated through Skype conferences. Noah chose this area because his grandparents live a few miles away from the chasm. Due to this village being close to heart, Noah recognized and communicated the need for this bridge. Here's a little information on the people we're working with. Noah finds and leads community projects in Kenya and delivers the ideas to his partner, Dr. Schneider. Dr. Schneider then researches the feasibility of the projects and brings them to the one and only Scott Schrake, who then gives students the opportunity to join the project.
During the research phase of the process, we considered the problems of the old bridge in order to develop an improved design of the new bridge. We also researched other pre-existing bridges of similar dimensions to get a good idea of what to expect in terms of pricing and materials. We initially planned to design a suspension bridge, but we considered other types of bridges to make sure that we had chosen the strongest type. After looking into the truss, beam, and arch bridge styles, we concluded that the suspension type is indeed the best option.
After presenting our ideas to professionals, we received helpful feedback. When modifying our design, we should be mindful of the modulus of elasticity and maximum shear force that our materials can withstand. We need to make sure the bridge satisfies Kenya building codes and has a safety factor of 1.5. So looking forward to continuation, we need to update and finalize the design, use the modulus of elasticity to determine minimum dimensions of the bridge, fundraising is key, and plan future interviews with the community partner, Mr. Jan Snyder. Keep in mind questions such as,
what are the exact dimensions that the bridge needs to incorporate? You should also request more images of the area.
Make sure you use the modulus of elasticity of materials to figure out the minimum requirements for the bridge thickness. Figure out effective fundraising techniques, and look into cable supports and materials.